Hello everyone, my name is Lum Song Sing. So today I will present about the water quality assessment in Pulau Payar Marine Parks. Introductions. Water quality can be defined as a metric that evaluates the use of water for various purposes by using multiple parameters such as biological, chemical, and physical parameters. So we usually use water quality index to define these tested parameters to see if they exceed the standards. Water quality index is also one of the most common methods to use to define these parameters. Pulau Payar is an island with beautiful reef and exotic marine life. In this study, in situ parameter and nutrient content will be assessed to determine the water quality around the Pulau Payar marine parks. Literature review. In situ parameter refer to the parameter that can be obtained directly at the sampling sites. The words in situ is a Latin phrase that translates literally to on sites or locally. These water nutrients are important to aquatic organisms. Generally speaking, water nutrients usually exist in small quantity in a healthy water bodies. So this table on the right hand side is the water quality standard by Department of Environments, which is the Malaysian Marine Water Quality Criteria and Standards, MMWQS, that I will be referred a lot in discussions. Methodology. So this figure on the left is the sampling station ABCD in Pulau Payar Marine Parks. The picture on the right is our group photo before the sampling is done. The water quality assessment was done on the 10th of April 2021 during the CMCO. No pre-field survey had been done due to travel restriction between states. The Fishery Department had approved a research permit to ensure that the sampling trip would be smooth and legal. The sampling was done between 10 a.m. to 5 p.m. The data collection from this study was divided into two stages: in situ parameter and laboratory analysis. All the in situ measurements are instant results that you can get in Pulau Payar, but the lab analysis had to be done when we are back to bioschool. YSI Professional Plus handheld meter rely heavily on measuring the in situ water parameter in this study. The picture on the right is YSI meter. The other picture is just showing we are taking the in situ parameter in Pulau Payar Marine Park. Refractometer and turbidity meter were also used to assess the in situ parameter. The picture on the left is turbidity meter, the picture on the upper right is refractometer, and the last picture on the right bottom is showing that we are filtering the water sample so that it can be preserved longer for the lab works. A handbook for basic water quality analysis is my main reference for all laboratory analysis. The picture on the right is me trying to get a standard curve for water nutrients. Result: pH. Figure on the left illustrates that the pH obtained throughout all sampling stations across all depths were rather consistent, ranging from 7.82 to 7.87. The highest pH value and the lowest pH value doesn't deviate much. Dissolved oxygens. From the figure on the left, you can see that the concentration of DO was higher in sampling stations C and D when compared to station A and B. Water temperature. Figure on the left shows that the most water temperature recorded fluctuates between 29.5 to 30.5 degrees, with only two values that were deviated from this range, which is station B on 3 meter and 4 meter depth. Salinity. Figure on the left shows that the salinity across all sampling stations at all depths range from 32 to 32.5 ppt. It is also observed that the salinity increased as the depth increased. Photosynthetically active radiation, PAR. The figure shows that there is an obvious clear trend of PAR decrease as the depth increase. Turbidity. Figure on the left shows that the turbidity range from 0.61 to 0.837 NTU. This is a very consistent range of data across all stations and depth, similar to pH. Total suspended solids. Figure on the left shows that the range of TSS is from 62 to 89 mg per liter. All stations were observed to have higher TSS at the bottoms compared to surface, except station B that has higher TSS at surface. Chlorophyll A. This figure shows that the concentration of chlorophyll A ranging from 0.0001 to 0.001 mg per liter. The chlorophyll A exists in very small amount across all stations. Nitrites. This figure shows that the nitrite concentration ranging from 0.005 to 0.025 mg per liter. At the surface of station D, it was the highest among all stations and depth, which record 0.025 mg per liter. Phosphate. Figures show that the bottom of station A had the highest phosphate concentration of 0.129 mg per liter. The phosphate concentration for other stations and all depths range from 0.009 to 0.016 mg per liter. Ammonia. Figures show that the highest ammonia concentration was 0.0906 mg per liter observed at the surface water of station B. The ammonia concentration for other stations at all depths ranged from 0.023 to 0.045 mg per liter. Discussions. This pH value is slightly lower than the average pH value by the marine standards. However, it is still within the optimal range for marine waste by the standard of MMWQS and NADZENS. In Pulau Payar marine parks, many coral reef, colorful fishes, and other beautiful organisms can be spotted in these regions. This produces a high amount of respirations and result in slightly lower pH value. The DO in Pulau Payar is lower than the standard of MMWQS. Since DO concentration fluctuates between seasonal and daily cycle, a repetitive sampling should be done in the future to improve the accuracy of data. Sampling station C and D recorded a higher amount of DO concentration than sampling station A and B. This can be explained by there are docks near to sampling station A and B, thus reducing water current and contact surface area with the atmosphere, which lead to a lower rates of diffusions of oxygen into the water body. The result also show a clear trend of increasing DO concentration along with the increase of depth. This can be explained by the fact that there is a healthy coral reef ecosystem at the bottoms of all sampling stations, which produce dissolved oxygens via primary productions. The water temperature of Pulau Payar Marine Park was still within the optimal range of water temperature by the standard of MMWQS. The only two data that deviate significantly from the rest are Station B at 3 meter and 4 meter depth. The dock at Station B provide a shallow cooling effect to the surface but not to the bottoms of Station B. The sampling time at Station B was during the cloudless settings and received the maximum sunlight exposure at 12 noons compared to other stations. All the data obtained in this study were within the optimal range of salinity by pore. The salinity level is important for water quality assessment as it could affect the density of marine water, circulation of ocean currents, and others. This shows that the circulation and density of marine water in Pulau Payar is normal. The PR value at Pulau Payar Marine Park reached 1,843 micromole photons centimeter deciseconds at its peaks, which is relatively high compared to other open oceans. The low turbidity support this at Pulau Payar. Thus, a higher amount of light can penetrate through the deeper region of the oceans. A high PR levels on the water surface could cause phytoplankton to be exposed to irradiance beyond the optimal level. This can lead to a lower amount of chlorophyll A and dissolved oxygens at all stations in the shallow region of Pulau Payar. All sampling stations and depth recorded turbidity less than 1 NTU by the standard of pore. It is crucial to assess the turbidity of Pulau Payar Marine Park as it shows that there was enough light that can penetrate through water for optimal level of photosynthesis. This is coherent with the PAR, as it still indicates that there was still relatively high light penetration even in 9 meter depth. All sampling station and depth recorded turbidity less than 1 NTU by the standard of pore. It is crucial to assess the turbidity of Pulau Payar Marine Park as it shows that there was enough light that can penetrate through water for optimal level of photosynthesis. This is coherent with the PAR, as it still indicates that there was still relatively high light penetration even in 9 meter depth. When compared to MMWQS, the TSS of Pulau Payar Marine Park exceed the Class 1 water bodies by a large margins. This shows that the suspended particle in Pulau Payar Marine Park was quite high for sensitive marine habitats as it ranged from 61 to 89 mg per liter. There was some rusted iron and abandoned steel building material that can be found near to all sampling sites. A tremendous amount of fish activity could cause sedimentation resuspensions, thus steal out the slate, decaying plants and animal matters. The high amount of TSS could also be influenced by the illegal human activity that near to the sampling site that we are not aware of. All stations were found to have higher TSS at the bottoms when compared to the surface, except for Station B. It suggests that the construction of the dock near to Station B can cause sedimentation to the reef as the construction was just built. Judging from the combination of PAR, turbidity, and TSS, it shows that the Pulau Payar Marine Park is optically clear water. The high amount of TSS was not enough to stop the light penetration even at 9 meter depth. chlorophyll A concentration were observed to be very small across all stations. There was no significant difference across all stations. Primary production is not high in these regions, and the rate of primary production was regulated by water temperature, nutrient availability, and turbidity. The low amount of phosphate and turbidity could explain why the chlorophyll A and DO concentration were relatively low across all stations. Nitrite exists in a very small amount and belong to the class 1 water body in mmWQS. The low concentration of nitrite across all stations and depth were affected by the relatively low DO availability. It has been found that the dissolved oxygen concentration will affect the rate of nitrifications. A low amount of nitrite would also suggest that the fish in this region are healthy, as nitrite is a famous fish toxicant that can disrupt various physiological functions of fish. The bottom of station D was the highest among all stations. This can be explained by there's an erosion of natural deposits, which lead to a higher amount of sedimentation resuspension. Thus, excess nitrite was transferred into the surface via ocean circulation current. All water nutrients exist in a very small amount and belong to the class 1 water body in mmWQS. Since pH was slightly lower, it will also reduce the ammonia and phosphate in all sampling stations. The low amount of phosphate suggests that the primary production in this region was not high, as phosphate is the limiting factor for photosynthesis. The bottom of station A had detected a relatively high amount of phosphate compared to other stations. This suggests that there was a high amount of fresh decomposition of dead organic matters or phytoplankton in the bottoms of station A. The low amount of ammonia across all stations and depth suggests that there is no illegal industrial activity, midnight dumping or fertilization runoff from agriculture near Pulau Payar marine parks. Marine fishes in these regions also face a very minimal risk of ammonia toxicity. Surface of station B is the highest among all stations at different depths. The higher amount of ammonia at the surface of station B is due to the shading provided by the dock in station B, so more fish will gather and the excretion of nitrogenous waste from animal will be high. Conclusion: most of the environmental parameters and all nutrient contents are still within the optimal range by various standards, with the exceptions of TSS and DO. However, before any conservation effort is done, more study with different time interval on water quality in Pulau Payar marine parks are needed to ensure the accuracy of the research data and give more options to the Departments of Marine Park Kedah for the implementation of policy. Lastly, I would like to express my greatest gratitude to my supervisor, senior and bio school. Without them, this thesis will never be completed. That is all for my presentation. Thank you.